Hello, AP Statistics students. Welcome to AP Free Response Review Time. In this video, we are taking a look at number 3 from the 2019 exam. This one's all about probability. So, a medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The responses were categorized as never, sometimes, or always. The relative frequency of each category is shown in the table here. All right, so we got all the relative frequencies. So they don't give us counts this time. They give us the probabilities or the percentages for each category. So one person from the surveyed will be selected at random. What is the probability that the person selected will be someone whose response is never and who is a woman? So we want the probability that someone will say never and they are a woman. It's a joint probability. Hopefully it makes sense that they are just looking at this one right here. Now, because it's a relative frequency, we don't have to divide by the total. It is just 6%. Now, technically you can actually, just dividing by 1 doesn't change anything. All right, part 2. What is the probability that the person selected will be someone whose response is never or who is a woman? All right, one or the other. So what cells are we looking at there? So someone whose response is never are these ones right here. Or they are a woman are all of these right here. Now you can see there's some overlap. So there's a couple of ways to do this. Because they gave us all the numbers, we can just add them up. All right, add up those 1, 2, 3, 4 different numbers. Perfectly fine to do that. A slightly easier way would be to take the probability of never plus the probability of being a woman. Now, you can see how that's problematic, right? Because right now, we are double counting that part right there. And so we have to subtract that off. Because we double counted it, we subtract one of them off. Minus the probability of never and being a woman. Might be a little bit easier that way. So 0.12 plus 0.53 minus 0.0636. I'll let you add and subtract that out, but that's generally how that goes. All right. Last one here. What is the probability that the person selected will be someone whose response is never, given, there's our big word there, given that the person is a woman? All right, now let's see. The probability that we are never given we are a woman. Now this type of thing is much more intuitive if you're given the numbers. If we are given the actual counts, it makes sense that for this one, let's see, never given you're a woman. So it would be this one divided by this one. Now that makes a whole lot more sense if it's a count. All right, if it's a count, it makes less intuitive sense if it's with a relative frequency. But it's the same thing. You do 0.0636 divided by 0.53. Which is where the formula actually comes from. This is technically, that gives you your answer, but the formula that you look up in your formula sheet says it's the probability of A and B. All right, think of this as A and this is B divided by the probability of B. Well, A and B, that's the 0.0636. That's what we found here. That is this cell right here. And the probability of B, the bottom one, is the probability of being a woman. In this case, 53%. So it's the same intuitive idea that you would do with counts with the relative frequency. All right. Next, for the people surveyed, are the events of being a person whose response is never and being a woman independent? So is the response never independent of being a woman? Justify your answer. So, what is the probability of saying that you never take your medication? All right, so that will be probably 12%. The probability of never is 12%. So the independence question asks, does that opinion change if I tell you this person is a woman? What is the probability of never given that you are a woman? I guess now if I had actually done this calculation up here, I would be able to answer that right now, but I didn't, so I actually have to type those numbers in. So what is it? 0.0636 divided by 0.53. What does that actually give us? Hey, 0.12. They are the same. So my opinion didn't change. That means the one does not depend on the other. They are independent. A never response is independent of being a woman because these probabilities are the same. They are independent of one another. Now, if that had substantially changed, then they would be dependent. They would not be independent. Now, there's not a causal relationship there. All right, don't use the word cause. But if those probabilities are different, they are not independent. They are connected somehow. All right, last one. Assume that in a large population, the probability that a person will always take medicine as prescribed is 0.54. All right. If 5 people are selected at random from the population, what is the probability that at least 4 of the people selected will always take the medicine as prescribed? Support your answer. So here, the very first thing we got to realize is this is a binomial situation. Okay. So one thing you don't have to do that I am going to go over, it does satisfy bins. I checked, you did not have to satisfy bins in this case, but just to show you that it is a binomial situation, let's run through it. So the B, is it binary? All right, is the answer yes or no, one or the other? And in this case, yes. They either do take it as prescribed or they don't. The B is satisfied. I, are the observations independent? And I think it's pretty safe to say that they are independent. N, number. All right, what is do we have a set number of trials here? And yes, 5 people are selected at random. We're going to look at 5 people and 5 people only. 5 will be the number of the counting. The counting will be 5. S, is it the same probability the whole time? Yes, it's always 54%. This is a binary situation. We want to know how many successes do we expect to have if we did this 5 times? If we looked at 5 people. Well, more specifically, what is the probability that at least 4 of the people selected will always take the medication as prescribed? Support your answer. So, the probability of at least 4. Now, if you're lucky and you have a Casio, this is really easy. All right, this is a binomial. I got to do a little bit. Binomial situation. You have to tell them the number, n equals 5, and p equals 0.54. Now, if we have a Casio, or even some of the newer 84s, I think allow you to do the upper and the lower, and this is really easy. Playing for time as my, there we go. All right, let's make this a little bit bigger. Oops. There we go. This is simply a binomial CDF. So we go menu, statistics, distribution, binomial. Oh, it's been a while since we've been in a binomial. CDF, where the lower is going to be 4 and the upper is going to be 5. We have 5 trials, and 0.54 is our probability. 24% chance. There's a 24% chance. So we're doing a binomial CDF. Where the lower is 4, the upper is 5, and the number is 5, and the probability is 0.54. And that gave us, what was it, 24%? 24%. There's a 24% chance that at least 4 of the people selected will always take the medication as prescribed. Now, how do you do that on an 84? Because I'm pretty sure if I go to the binomial CDF on the 84, it doesn't give me lowers and uppers. If yours does, you are in luck. So binomial CDF, you got to search for it a little bit. Trials is 5, got that. P is 0.54, we got that. Oh, it doesn't give me lower and upper. So yeah, some of the older 84s, they only give you the left-hand area from 0 to this number. All right, so I need to go from 0 to 3. All right, 0 to 3. 75.85%. So what I have to do is 1 minus that number. All right, so this is 100%, and this is from 0 to 3. What's left over when I subtract those two? 4 to 5. Okay, so if I have, hey, from 0 to 5 is 100%, right? Yes, it's nice if I can go from 4 to 5 and have my calculator give me that number. But if it can't, I have to do from 0 to 3 and then subtract from the whole to give me the leftover. Okay, so I have to do 100% minus from 0 to 3, and that should give me the right answer. Let's double check here. 1 minus 0.7585. Yep, 0.24. There's a 24% chance. All right, that is the binomial distribution in a nutshell. We will talk more about that next time.